Okay, we're going to go over some like tricks to enter matrices in your calculator. So this is some examples from our notes. So let's just go ahead and look at how to actually enter a matrix in your calculator. So right here above where it says x to the negative 1, it says matrix right here. So, and it's in blue, so you can do second and then that button. And this is where everything is from our matrices. So from here, if I want to enter a matrix, then I have, these are all my different matrices names. I'm going to go over to edit and I'm going to hit enter on A. So let's say I'm doing, how about example A right here. My first matrix is this, it's a 2 by 2. So I change this to say 2 and I scoot over here by 2. So now I have a 2 by 2 matrix and I go ahead and I just put my numbers in. If you put in like a number and then press enter, what it will do is it will take you to the next entry in that row. It works across by rows. So now if you do -1 and hit enter, it goes to the next row. 3, hit enter, it goes to the next entry. So once you get your numbers entered in there, we're going to go and we're going to second quit. And we're going to go back to matrix, second matrix, and we're going to go edit, and we're going to edit matrix B. We're going to make it be a 2 by 2, and it's going to be 1, and then 2, 4, and then -2. Okay, and so we can get out of there. And so we're back to just our regular screen. So we can now write that we want, choose your matrix, second matrix, and just right here, these are the names in the matrix. So hit enter on A, and then put plus, and go back second, and then matrix, go down to B, hit enter on B, and then hit enter, and there's your solution. So you can add, subtract, multiply, divide, etc. there with matrices. If you were wanting to do a scalar multiplication, then you could do 2 times. Let's do matrix A. And so it will also do a scalar. All right, you could do matrices, not necessarily with variables, but in terms of with multiple, like more larger operations. So if we wanted to multiply matrices, we could do matrix A. And then you can either put times matrix B or you could just put matrix B right next to it and it knows you're multiplying and it'll multiply matrices also. It will give you an error if the dimensions are a mismatch, meaning that they cannot be multiplied. So if you try to multiply something that has the wrong dimensions, it will not let you. Okay, when you want to find the determinant of a matrix, we have our formula. It's fairly easy with the 2 by 2. It gets more complicated with the 3 by 3 and so on. You can do any square matrix, like a 4 by 4, 5 by 5, so on. But the math to it is getting more and more complicated. So what we can do is if we go under where it says second matrix, go over to math. Here's all our operations. Let's do determinant right here, the first one. And so determinant, and then choose matrix A. And so it found the determinant of matrix A. And so it can do that to any square matrices. Now, if you try to plug in something not square, like a 2 by 3 or a 3 by 5 or something like that, it's not going to be able to find it and it will give you an error. Okay, so we talked about how to do determinant. So the same concept here, right, of us being able to find the area of the triangle. So you could do like the exact same thing. Now, granted, this would be, let's see here. This would be a matrix. That would be, we'll make it be C. Let's go edit matrix C. All right, so let's make it be a 3 by 3. Okay, and remember what we did is we plug in our numbers and then the last column is just ones. So I'm going to do 2 and then 3 and then the last column is a 1. And then I'm going to do the 0.3. Now I'm going to do -2 and then the last column's 1. And then I'm going to do -4 and -3 and the last column is 1. All right, and so let's get out of there. Let's do second quit. All right, so remember that the plus minus indicates that you have to use like the appropriate symbol. So if it comes out negative, we'll just switch it to a positive. So we do 1/2 times. We want to do the determinant. And so we do second matrix. We choose the determinant. And we want to do the matrix we just did, which was C. and I already did the 1/2. So it came out to be negative 18, and remember the plus minus means we just do positive 18. Okay, so in terms of finding inverse matrices, right? So when we want to know what the inverse is, let's just do the inverse of A. We can do matrix A. And then we want to do the inverse notation. You can see right here is A to the negative 1. And so if we then press this button, x to the negative 1, it just pops up a negative 1. Or you could do the exponent and then type in negative 1. It would work either way. So like this one was a mess, but this is its matrix. It's its inverse matrix. Okay, so that's how we can find the inverse matrix. All right. And then what is kind of cool is like if we go down here to where we had like our different problems right here, and it was how to solve it, right? And remember that you did the inverse of matrix A times B. So let's go ahead and go to our matrix. I'm going to go edit matrix A. So if I did this problem, then it's still a 2 by 2. It was 2, 5, and then it was 1, 3. I'm doing all the numbers in front of the variables, right? And so then let's go and get out of there and go back to matrix B. And let's edit matrix B. All right, it needs to be a 2 by 1, and it's 3, and then 2. All right, get out of there. And so remember how we do that is we take the inverse of matrix A times matrix B, and the order does matter. So we do matrix A, and then inverse, that's that negative 1 button right there. And then you can put times, or you can just go straight to matrix B. And so it just solved a system. So the x is negative 1, the y is 1. So this is a great way to do this if you were doing something like this on the ACT. If you could remember how to do this quickly, then that would really save you time on the ACT in terms of just being able to get the right answers quickly.